Okay, so for exponential functions, we're going to focus on finding domain, range, and behavior and asymptote. And then we're going to use those to solve exponential problems. Okay, and then you guys can see from here, it says there's a colorful graph on page 304. And that's just going to show you some of the different exponential functions here. Okay, so this is y to the power of 10x, 5x, 3x, and 2x. So the larger that base number is, the steeper the exponential function is. And then remember, for decay, it's not a negative value, it's a base value that's in between 0 and 1. Okay, so that might be something that you guys remember from last year. Okay, so we're going to complete these questions after we do example 1. We're going to look at these forms. So f of x equals a to the x. That is your exponential function. Okay, it has a domain of all real numbers and a range from 0 to infinity. Okay, y equals 0, which is the x-axis, is a horizontal asymptote of the function. Okay, and so it'll look similar to one of these. So one of these is growth, one of them is decay. Do you guys know which is which? Well, but growing where? Because they're both going to infinity at one point, right? Yep, so it has to go from left to right. So for here, your growth, it always is going to go up from left to right. So I'm just going to say from L to R. Okay, and then decay is going to approach the x-axis on the right, or if you have a different asymptote, it's going to approach that. Okay, now both of these are going to have an asymptote at y equals 0. So it gets closer and closer to that value. And exponential functions are usually one of the first functions you learn about that have asymptotes, and it will not cross those, which is why when we were talking about rational functions, I had to keep telling you that doesn't happen all the time, okay? Because for these, it does not. So if you have decay, your base is in between 1 and 0. Okay, for growth, your base is going to be greater than 1. So we call the base B. Notice in both of these that your range is going to be the same. All the points are above the x-axis. So the range that they gave you, 0 to infinity, that is your range. Okay, here they tell you f of x equals ax for a is greater than 1. A in this case is your base. Same thing with this. Okay, if they give you this formula, they're saying that a is your base. Okay, so we're going to do number 1, and then we're going to come back and answer those 2 questions. So we are going to graph the function. We have to state the domain, the range, the asymptote. And then we're going to be using interval notation for this. And your quiz over this section in the next section is Monday, and your quiz is going to ask you for interval notation. So f of x equals 10 to the negative x. Okay, so we're going to use our graphing calculator to help us with your table. Okay, and that's fine. So you are going to have your calculator on your quiz. So you have 10 to the negative x. Okay, I need to zoom and go back to my standard 10 by 10 window. Now, I love these new calculators because you see the blue line is going to keep going here. That's why I love them. Because if you don't have that, sometimes it looks like it's stuck. Okay, and then the other one, it's just hard to see here. So another good resource to use is Desmos. Yeah, so because this is what I grew up with, right? And you can't see the difference between them. So that's why we're going to use our table. We're going to use our table to look at both. So when we look at your table, okay, you're at negative 4 is at negative 10,000. That's kind of a lot. At negative 2, you're at 100. Negative 1, you're at 10. We really want at least 5 points on there, so we are going to do the negative 2, 100. We're just going to set our scale. At 0, you have 1. Okay, now at 1, I want you to think about this. If you are doing 10 to the negative 1, do you guys remember that 10 to the negative 1 is the same thing as 1 over 10 to the first? So that 0.1 is 1/10. When you plug in 2, if you have 10 to the negative 2, it's 1 over 10 squared. 10 squared is 100. Okay, so I want you to understand that because that is going to lead into something else we're going to study this chapter. So it's important to remember those things. Okay, and then if you keep looking here, you can see the scientific notation happening. It's getting closer and closer to 0. It's never going to cross it. You can always like do your table start at 500 and see what happens. Oh, that's really too big. So it will end up rounding it to 0 because the numbers are just so large. Okay. Will you just check that on your calculator? I wonder if all of them round it to there. You can also on your graph, if you use your trace and you just keep going, you'll see it gets like closer and closer and closer to 0. Okay, and eventually they just get so close that you're gonna round it. Okay, so the asymptote for this one, oh, maybe I didn't put 100 on there. You want to go by 2s and just put the 10 on there. 2, 4, 6, 8, 10. And then we can keep this by 1s. So this is your y by 2s, here's your x. Okay, and then because you are going to have some of these on the axis, sometimes I just use my highlighter because it's easier to see. And that's your y equals 0. So that is your horizontal asymptote, y equals 0. Okay, and with the exponential functions, you are only going to have that horizontal asymptote. All right, so at negative 1, I'm at 10. At 0, I'm at 1, which is halfway in between. Now, once you get here, you know that it's getting closer and closer. Okay, so we're just going to estimate what those are and then just connect it with your curve. And you can put it right along the top there. Okay, now your domain is all real numbers. Your domain should always be all real numbers. And then your range, the lowest y value to the highest y value. The lowest y value it's going to go to is above 0, so it's 0 to infinity. You need a soft bracket because for all of these, it is not going to hit the horizontal asymptote. Okay, so now let's try this one. So I want you to plug that into your graph. I want you to create a table. Nope. So the plus is not in the exponent. So it should look like this when you plug it in. And now when you graph it, you can see it's approaching a different value. Do you guys know what number it's approaching, getting closer and closer to? 1. Yep, and then, oh, mine's still up there. Okay, so if I start at 0, again, you can see this is rounding it because they are getting so incredibly small here. Okay, so at -2, I'm at 26, and you guys can make you'll have your own graph paper for these, so if you want to include that value, you can. Okay, so you have 1 and a 1.2, you have 2, 1.04, and then you could also write those as fractions. If you have 5 to the -1, it's just 1/5 plus 1, so this is 1 and a fifth. Okay, if it's to the -2, it's 1 and 1/25. All right, and then let's go ahead and put in our horizontal asymptote. At y equals 1. So, and I just make these by 1, so I'm going to say this is my 6, and I'm just going to extend it there. Okay, so at -1, we're at 6. At 0, we're at 2. Then we're at 1.2, 1.4. So again, when you're connecting these, you have this curvature. Gets closer and closer to the line. Okay, and then we're going to do the domain, the range, the asymptote. So domain, all real numbers, interval notation. Your range always goes from your lowest y value to your highest y value. So your lowest y value is 1, highest, infinity, and then your horizontal asymptote, y equals 1. Okay, now this one is called h of x. H of x is 2 to the power of x minus 4 plus 1. Okay, so go ahead, plug that in, and then I want you to graph it. Okay, so we can see that this is a decay graph. When you're doing your table, you have -2, -1, and you can round this. So when you're plugging in the -2, what's -2 minus 4? -6. Then you guys know what 2 to the 3rd is, right? 8. So then 2 to the 6th is 8 times 8. Yep. So it'd be the 1/64th plus 1. So it's 1 and 1/64th. You can also just round your values like the 1.02, that's fine. Okay, so for -1, you have 1.03. Again, I'm just reminding you how to do that because it is going to come in handy when we talk about logs. Okay, now here we're getting into some bigger numbers. Your 2, your 3, your 5, your 9. So when you see those, these are going to be the more valuable points to use. Okay, so when you're doing this, let's go by 2's again. So 2, 4, 6, 8, 10. Okay, and then we can go by 1's on here. So you can see here it's going to 1. So if we went by 2's, we're just going to put this halfway in between. We're going to label it y equals 1. You can also just put that that's your horizontal asymptote. So at 6, I'm at 2, 4, 5. Okay, and again, these are just getting closer and closer to your asymptote there. Okay, so you can follow that right on your line. Okay, and then domain is still all real numbers. And your range, even though it is decay, the lowest value is going to be what? 1. The highest value, infinity. Okay, so domain, range, horizontal axis. All right, now, whenever we talk about exponential growth, we always talk about animal populations. So a rabbit population at a local zoo was initially 200 rabbits. And it's estimated that the population is doubling every year. Okay, so we're going to find a function that models the number of rabbits after t amount of years. Okay, so earlier today, I reminded you of this. And you guys remember that this was the initial value. And then B is what we call the common ratio, or the ratio. So what it's increasing by. Okay, so we can use that. If it's initially 200, it's going to be 200 times. If it's doubling, that means the base is 2. Okay, and then you can just use t for the time. Okay, and they tell you that t is in years. So this is your function. So we're going to estimate the population after 7 years. All we have to do is plug in 7 for t. So will you go ahead and calculate that? And then we'll just label it with the All right, how many rabbits are running around? 25,600 rabbits. I know. I don't know. I feel like I had rabbit stew once, though. Don't hate me, I was just a child. I was just a kid. And it was kind of like sausagey. I have an uncle who's a hunter. He makes like good jerky, so I've had snapping turtle before. Maybe I should put on one of your next quizzes, what is the weirdest thing you've ever ate? Would that be a fun question? All right, so let's answer 1 and 2 because I forgot. So how do you find the horizontal asymptote? So we use the graph for these, but you don't have to use the graph. You should actually know right from looking at your equations, right? So this one was 0. These were both 1. So how can you find what the horizontal asymptotes are? Yeah, there's 2 ways, right? So you can either find the value that's added or subtracted to a to the x, we'll just call it that term. Okay, or it's the line the graph approaches, which is how we find it. The line the graph approaches. Okay, and then if there was a reflection of the parent graph, so if it was a reflection of this guy, okay, it would look like this. So let's talk about how that would affect the range. Okay, if it was a reflection over the x-axis, then what would our lowest y value be? Yep. And the highest one would be, if it was the parent function, 0. Okay, if there was a reflection over the x-axis, it wouldn't change, right? Because if it was over the y-axis, it would just look like this. And isn't that what we have here? Yeah, so it wouldn't affect it. It would still be 0 to infinity. So the only thing that would affect it is the x-axis reflection. Okay, and I wanted to make sure we went over that because we didn't have any that flipped, but you will see some, and you have seen some before. All right, so we are going to use the model y equals a times b to the x as the common model for an exponential function. So when they're asking you to find one, if it's doubling, you plug in 2 for b. If it's tripling, you plug in 3 for b. Okay, and you guys have already had some practice with that by completing your preview worksheet. A very common application is compound interest. Again, this should feel a little bit familiar to you. Compound interest is calculated by the formula a of t equals p times 1 plus r over n to the nt. And that is something that you will be given on your quiz. There'll be 2 equations, and they'll just be given to you at the top, okay? So one thing you need to keep in mind when you're doing this is do not round until the last step. If you round, then you're not going to get as an exact of an answer as you could. So do not round until the last step. Okay, so A of t is the amount after t years. P is called the principal. The principal is the same thing as the initial value. Okay, R is the interest rate per year. That is when you have a percent written as a decimal. You may remember that. And then N is the number of times interest is compounded per year. So quarterly, 4 times per year. Semi-annually, think of semester. How many semesters do we have in a year? 2. Okay, and then T is going to be the time in years. Okay. All right, so for example 3, if you have $2,500 invested at an interest rate of 2.5% per year, compounded daily, you are going to find the value of the investment after the given number of years. So for A, your value is 2 years. So already in the problem, they've given you a ton of information. This is what you start at, so that's your principal. Your 2.5%, when you convert that to a decimal, do you guys remember how to do that with a percent? Yep, you can divide it by 100. You can move it 2 decimal places to the left. So 1, 2 would be 0.025. Okay, if it's compounded daily, how many days are there in a year? Yes, and you can just use 365. Not 365, not 4. In case some of you are thinking. And then when you're finding the value, you're finding the A of T. Okay, and then your time for this is going to be 2 years. So what's important with this is you practice plugging this into your calculator so that you know how to do this so that you can get the right answer. You can plug it all in at the same time. You just have to make sure you use your parentheses correctly. I like to start on the inside of the parentheses and then work my way out. Okay, and I follow just my order of operations. So I don't care which way you do it, just as long as we get the same final answer. So I'll do 0.025 divided by 365. And then I'll add 1 to it. And then I'll raise it to the power of 365 times 2. And then I'll multiply it by 2,500. Now, anytime you're dealing with money, the problem is not going to necessarily tell you what to round to, because in America, where money is always rounded to what? The nearest hundredths. Okay, so it should be 17 cents. So it's always to the nearest cent, right? That's 2 places after the decimal, so that's expected. All right, and then I want you to try part B. And we'll try plugging all that in at one time and see if we can get that to work. Okay, and so this is the same setup, except now instead of 2, you have 6. Okay, and if you're doing that on your homework and there's like an A and B and everything's the same, I'm okay if you put like a comma and then just change the 6. That's fine with me. And then, so for this one, it will follow the order of operations here because it will divide those, then add, and then do the exponent. So if you want to try to plug it in yours to make sure yours does the same. The newer calculators let you put the exponent there. Sometimes they have parentheses. And then again, we're going to round that to the nearest hundredth. Okay, and then let's just make sure you can get those on your calculator, and then if you want to read through the next problem and set it up. So this one says find the present value of $10,000 if interest is paid at a rate of 7% compounded semi-annually for 4 years. So right away I see the years, I know that's going to be my T. Semi-annually is how many times? Twice, so that's going to be your value of N. The rate of 7% means R is going to be 0.07. Now it says find the present value, so that means you're going to find the P value. So then this 10,000 has to be the amount. This is your A of T. So when you're plugging this into your equation, it's your 10,000 equals P1 plus, it's the rate over your N value to the power of N times T, so 2 times 4. So what we're going to do is we're going to solve this for P. Okay, and this is where you need to be careful with your rounding. So for this, I have 1 plus 0.07 divided by 2. So in here, I have P to the 1.035, okay, to the power of 8. And then if you want, because this is going to be a decimal, you can just divide both sides by 1.035 to the 8th power, because you don't want to round yet. You could also do that and then divide. So you can do 10,000 divided by 1.035 to the 8th and get your answer that way. Or if you did 1.035 to the 8th power when you're working on your homework, you could just do 10,000 divided by second answer. So you're going to be using that answer key. So when we round it to the nearest hundredth, what's my change? How many cents do I have? Good. Okay, so this is the present value. Okay, and then the last thing we're going to talk about is the APY. That stands for annual percentage yield. Annual percentage yield. So if an investment earns compound interest, then the annual percentage yield, or APY, is the simple interest rate that yields the same amount at the end of 1 year. Okay? So simple interest is just this equation, 1 plus the R. This is where it comes from. The 1 is equal to 100%. Remember how we were turning percents into decimals? Okay, if it's 100%, it's 1.00. Okay, the R is going to be that rate for the year. So that's where it comes from. Okay, and then if it is 1 year, that means your time is going to be 1. So for questions that ask you to find the APY, we're going to be using the simple interest to help us with that. So find the APY for an investment that earns interest at a rate of 4% per year, compounded quarterly. Okay, so anytime it's APY, your T value is going to be 1. If it's compounded quarterly, that is your value for N. So quarterly, there's 4 quarters in a year. And you're going to set it up similar to how we did the first one, where you have your A of T. And sometimes instead of A of T, they'll just write it as A. That's fine. Okay, so A equals, and so it's P1 plus R over N, so 0.04 over 4 to the power of NT, so 4 times 1. Okay, so the setup is the same. Okay, and then we're going to calculate this. Do you guys know what 0.04 is divided by 4? It's just 0.01. Because 0.01 plus 0.01 plus 0.01 plus 0.01 is 0.04. Okay, and then what you're going to do is you're going to calculate this. Okay, this is going to be a big long thing. So 1.01 to the 4th power. Okay, so you have 1.04060401. Remember that this value here is going to be your simple interest. Okay, so this value that you created here, that is your simple interest. So if the simple interest is 1 plus r, okay, then that means your r value is just going to be what? Yes, and then it's going to keep going, 0.00401. Since that equals 1.r, we know that equals 1.0406. I'm just going to put dot, dot, dot. That means your r value is this. So to find out what the percentage is, just multiply it by 100. When you multiply by 100, what are you doing with the decimal? Moving it how many spaces? 1, 2. So that means your rate, your APY, is 4.06%. Okay, and you can just round that to the nearest hundredth. Okay, so to find your APY, whatever you get here, you can subtract the 1 from it, because your R value is just going to be this as a percentage. So you can multiply by 100 in your calculator, or you can just move the decimal 2 places. Okay, so I'm going to put up your 4-1